In the last section, we got a better idea of how to get some concrete results around the performance of our application. We're now going to start to refactor our index.js file here just a little bit, and then start to benchmark it to get a better idea of when clustering starts to not quite pay off so much. The refactor we're about to do is going to be just a little bit long, so we're going to try to get through it as quickly as possible, and then we will immediately start benchmarking our app in the next video. Okay, so let's get to it. So what we're going to do for the most part here is replace the doWork function. The doWork function definitely is good at simulating a big pause or some blocking code inside of our application, but it doesn't really do a good job of simulating true, actual work, like some computation, some fixed set of data that we have to chomp through. The doWork function always tries to pause for the exact same duration, and that doesn't really give you a very good sense of what's going on when it starts to come to clustering. So we're going to replace the doWork function with a different function that better simulates doing some real computation on our server. So I'm going to delete the entire doWork function. And then I'm also going to clean up the doWork function call from inside the root route as well. Now instead, we're going to reuse one of the same functions we used previously in this course. To simulate some amount of work inside of our cluster, we're going to use that pbk df2 hashing function. Now I don't want to rewrite that entire function out because I'm so lazy. So I'm going to open up my threads.js file, and I'm going to copy paste one of those function calls over to my server. So I'm going to get this one call right here. I'm going to go back over to my index.js file, and I'm going to dump it right into my root route request handler. I'm then going to take out the console log, and then to really simulate some amount of work that has to be completed before our server will respond to this request, I'm going to take that res.send and I'm going to put it into the callback like so. So this now means that anytime someone makes a request to our root route, we're going to calculate the hash, which for me on my computer takes just about 1 second, as we saw very many videos ago. And then after that 1 second of work, we're then going to send a response back to whoever made the request. The other thing I'm going to do very quickly is just make sure that I require in the crypto module before I forget. Now I'm going to make one other change here, and this change is going to seem a little bit arbitrary, but it's going to make understanding the benchmark results that we get much easier. Okay, so this is, again, it's going to be a little bit of an arbitrary change, but it's going to make understanding our benchmarks so much easier to comprehend. So I'm going to say that all of the children inside of our cluster will only have one thread available in their thread pool. Okay, so just one thread in the thread pool. To be clear, whenever we create a cluster, every single child has their own separate thread pool. So normally every child that we would create has a group of 4 threads that they can use for computation. But just to make these results a little bit easier, I'm going to restrict it to 1. And recall we can do that by placing a line at the top of our index.js file of process env uv underscore thread pool underscore size, and I'm going to set that equal to 1. This does not restrict the total number of threads in our entire cluster. It means that every child in the cluster only has 1 thread available. And again, for like the 3rd or 4th time, this is just to make understanding our benchmark results a lot more straightforward. Okay, so let's pause right here. We're going to come back in the next video, and we're going to start to do some more benchmarking, and we're going to see where clustering doesn't quite pay off so well. So quick break, and I'll see you in just a minute.